talk about triangles. All right, still continuing about talking about triangles. So let's just go through, do this as a quick warm-up. Gives us an angle bisector and perpendicular bisector. All right, so what did that tell us from last unit? Perpendicular bisector meant those were cut in half, and angle bisector means that angle is cut in half, and we also know that that side's also the same, right? So DF is 8. All right, if the whole length D to F is 8, that means half of it, D to G, is 4. Likewise, DEF is 30 degrees. DEF is the entire angle. Half of that then is going to be 15 degrees. And then today, this is what we're going to answer by the end of it. Can 5, 12, and 13 make the side lengths of a triangle? Tomorrow, we're going to explore on what kind of triangle is that going to be. Is that going to be right acute right obtuse acute? So that's our plan, right? So today we're going to talk about this triangle inequalities thing, but really we're going to look at two different things. One, we know the side lengths of a triangle. We can label it as equilateral, isosceles, and scalene. But now after today, we're going to be able to order things from what is the largest side, what is the largest angle based off of information they give us. We might not know exactly all the degree measures or any of the degree measures, but we could tell which ones are going to be the longest and the shortest and stuff like that. So, and then the other one is, can certain side lengths be three legs that could be formed together to make a triangle. All right, so here's what we got. First one is equilateral. Equilateral, if all three sides are the same, then all three angles are the same. This one is isosceles. I know that because 5 and 5 are the same. So we talked about last unit, if the two sides are the same, then the base angles or two angles are going to be the same. And then scalene, none of the angles are going to be the same. All right, but I could tell based off of this diagram right here what the biggest angle is, what the smallest angle is, what the medium-sized angle is based off of the side lengths, okay? And that's what we're going to focus in on right now. So first off, ordering angles. The smallest angle is always opposite the shortest side. The largest angle is always opposite the longest side, all right? Short across from short, long across from long, okay? So when I'm looking at this, it says least, smallest to biggest. So I want to start with the smallest side, 17, go opposite of 17. That is pointing to the smallest angle. I don't know what it is, degree measure-wise, but I know it's the smallest. Then we just go in order. 20 is the largest, or medium size, then that's across from the medium angle. 24 is the longest side, that's across from the longest or largest angle. All right, pretty simple, right? Find the smallest. Just read the directions. Smallest, largest. So start at the smallest side. Points to the smallest angle. Medium side, medium angle, largest angle. All right, you guys try number 2. You can pause it because I'm just going to keep going through, okay? So smallest is 7. Smallest angle is C. Next is B. And last but not least is angle A. All right. Conversely, the smallest side is across from the smallest angle. All right. Shortest side, shortest angle. Longest side, longest angle. So same philosophy. Now with this, you might have to find out the angle measures. I might have to subtract from 180 because I know the three angles add up to 180. I have to find that missing angle is 68 degrees. Right. So now greatest to least. Find the biggest. Then the medium, then the smallest. Okay, so just read those directions, be mindful of those directions. Okay, can you order the sides from longest, shortest? Now start with smallest to longest, shortest to longest, all right? Go ahead, pause the video, try it out. Shortest, medium, longest. All right, don't know what the third angle is, add them up, subtract from 180. We're talking about shortest again, so 40 is the shortest. DE's middle. DF is the longest. All right, pretty easy, pretty basic. Now, the triangle inequality theorem. Two side lengths of a triangle is greater than the third side length, right? So can I take these three side lengths of a triangle, form them, or three side lengths, and put them together to form a triangle? The answer is no, right? No matter how hard I try, this little arm and this little arm are just not quite long enough to connect to make a third angle, to connect to make that third angle, right? Just is not going to happen. So we can look at side measures and know for sure which ones are going to make and which ones are not going to make based off of the lengths. All right, so we don't have to cut out pieces and try to form together the triangles like we are right here. Okay, and that's what this triangle sum theorem says. Triangle inequality, sorry. The sum of two side lengths has to be greater than the third. Well, I'm going to tell you right now, side note, you just need to check if the two smallest sides added together are bigger than the longest. Okay? That's what we're going to look for. So go ahead, pause if you need to write stuff down. I'm going to go through again. Okay? And then likewise, as we're going through the longest and the shortest and all that, XY, right, is across from, well, we used X and Y, so it's across from Z. So anytime you're looking at the sides and angles and not sure what to call it, well, look at the sides, use the missing letter. X and Z are used, so that means this one is Y. Likewise, if I give you angle Z, well then the two other letters are going to be the side it's across from, right? So you can use the visualizing Z is across from and draw the arrow, or use the letters, all right? So this is saying, you guys, if all those three are true, I'm telling you, let's not do that. Let's just find the smallest, two smallest, right? Because if I take, in this case, 24 is the largest one, if I add 24 to anything, either it's the smallest or the medium, guess what? It's already bigger than, don't have to add more to it. It's already going to be bigger than, right? If I'm adding 8 to it, well, 24 is already bigger than 17. So if I add more to it, it's going to be just more bigger, right? If we don't have to check that, right? Same thing, 24, well, it's already bigger than 8 to begin with. So if I add 17 to it, it's already going to be bigger. So I don't need to waste my time checking that. I just need to see if the two small sides added together is bigger than 24. 25 is greater than 24. Yes, this works out. They can be. All right, go to this one. Take the two smaller. 3 plus 3. Is that greater than 7? Is 6 greater than 7? Answer is no. Nope, can't be. And then 41 is the longest, so I have to do 35 plus 7. So just make sure it could be in any order. This is 42 is greater than 41. Answer is yes, they can be. All right, the one you have to look out for would be like 5, 6, and 11. All right, is 5 plus 6 greater than 11? Or is 11 greater than 11? The answer is no. 11 is not greater than itself. The answer is no. Okay, has to be bigger than. Can't be equal to, has to be bigger than. All right? And then last but not least, what happens if they give us two sides? Okay? Well, we don't know if these are the two smallest or the two, one's large and one's the smallest, that kind of thing. So what we do know is if these were the smallest, 3 plus 11 has to be greater than a number, right? So 3 plus 11 is 14. I can't be 14. The side length can't be 15 or 16 or 17 because 3 plus 11 has to be bigger than that, right? So what we do know is our side lengths has to be less than 14. And what happens if these aren't the smallest? What happens if 11 was the longest? What would my other side length have to be? Well, 3 plus 8 is 11, so I have to be bigger than 8 because I have to add the 2 to be bigger than 11. So what we're going to be doing, so I have to be greater than 8, less than 14, right? And so our final inequality is going to look like this. 8 less than x less than 14. We're saying our side length has to be in between 8 and 14. Now, what we're doing is we're going to add them, because that's what we did. We're going to subtract the two numbers, because it's essentially what we did. And then we're going to make our inequality. So that's our goal. Add them, subtract them, make our inequality. So if these are the two side lengths, they could be the two smallest ones. 28 plus 31. That's going to give us a grand total of 59. Then we're going to subtract them. So either those two are the smallest and I have to be less than 59, because if I'm bigger than 59, I'm not going to add and be greater than the third side. Or I'm going to subtract them. So this is going to be a wide range. Since those two are so close in size, then I'm going to have a longer range. So I'm going to be greater than 3. Less than 59. So you can write this like this, though, too. You could say I have to be greater than 3 or less than 59. I'm just writing it all as one. 3 has to be less than x, and that side length has to be less than 59. Likewise, add them, subtract them, make our inequality. All right, guys, you have